Today we will be solving equations with variables on both sides of the equals sign. So let's go ahead and try it. The whole idea here is to isolate the variable onto one side. So it doesn't matter which side the variable goes to, you just need to be consistent. And so I'm going to go ahead and move the constants to the right. Notice how I took away the constants from the left-hand side and bring the variables to the left. Notice how the variables are canceling out and moving to the left as I do these opposite operations. So I'm left with this 6r equals 6, and then I can go ahead and solve by dividing by 6 on both sides. So r equals 1. Well, taking a look at our next one, here we have some decimals, so you can either leave the decimals in or get rid of them. Since they're both into the tenths, I might just go ahead and leave them in for right now. And I'll go ahead and move some variables over. Now, I like to try to keep positive variables if I can. If it's too much trouble, I'm not going to worry about it. I'm going to go ahead and just add this 3/10 y to both sides to cancel it out from the left. And I'll go ahead and add the 12 to both sides. And so what I'm left with is when I add these together, I get 40. Notice how I had to carry 1 when I added the 8 and the 2. And this all equals, now 7/10 and 3/10 makes 1y. So I've solved the problem. Y is 40. That was pretty quick. The next one requires a little bit of combining of like terms first. So I'm going to combine the 3c and the negative 4c to make a negative c plus 1. Over here, I'll combine the 2 and this 3. Notice the signs I circle as well, so I know what operations to perform. So I got 5c plus 5. So from this point, I can go ahead and do some opposite operations. I'm going to go ahead and add the c to both sides. And over here, I'll go ahead and subtract the 5 from both sides. So what's left over? Well, when I subtract, I have more negatives than positives, so it's negative 4 equals 6c. So when I go ahead and do the rest of the steps here, I'm going to divide by 6 and just reduce the fraction. So I'm left with a negative 2/3 when I go ahead and reduce the fraction of negative 4/6. Looking at our next problem, it says that Justin and Tyson are beginning an exercise program to train for football. Justin weighs 150 pounds. Alright, so this is important. So this is like a starting point, so we want to start there. So he weighs 150 pounds, and he hopes to gain 2 pounds per week. Okay, once you see this per week, that typically means a variable. If we go to the question, it says, when will they weigh the same? And so when, meaning at what time or how many weeks will they weigh the same, and what will that be? So we know this is our variable amount. So that's the starting point. This is our variable amount. And we read on, and it says Tyson weighs 195 pounds. Okay, that's his starting amount. That's his constant. And hopes to lose. So lose means minus 1 pound each week. Each week. We don't know the number of weeks. Here, this guy, Justin, is gaining 2 pounds per week. So that's going to be positive 2 pounds per week. When will they weigh the same? Same means equals. So here's how we can do it. We've got Justin, and we're going to set that equal to Tyson. And so let's go ahead and set up our equation for Justin. Justin started at 150 pounds. That's his starting point. And he hopes to gain positive 2 pounds per week. Tyson starts at 195. And he hopes to lose. So that's why it's minus 1 pound per week. And when will they weigh the same? So this is going to give us the number of weeks in which they'll weigh the same. So I'll go ahead and add this 1w to both sides here. Again, I just chose that. I could have subtracted the 2 from both sides, but that would give me negative numbers, and I just preferred to have the positives. And then I'll go ahead and subtract the 150. Sometimes you can't get away. You'll have to deal with some negatives, but if you don't have to, might as well not. Less things to worry about. So I'm left with 3w. Here I have to subtract. That gives me 45. So now I'm ready to do the division, and I divide by 3, and that gives me w equals 15. So 15 weeks is the number of weeks that we are going to have to they'll have to train before they'll weigh the same if they follow this and one gains 2 pounds, the other loses 1 pound. Well, we're not done with the problem because they say, what will the weight be? Well, what we have to do from this point is substitute. Put that W, 15 weeks in for W, and figure it out. It doesn't matter which one you use. You'll get the same answer either way. So I just go with the easier one. 195 minus 15. Subtract those numbers, and you end up with 180 pounds. So after 15 weeks, that's the amount that weighs 180 pounds. Well, the next one says 4 times Greg's age. So we don't know Greg's age, so let's call it G. So 4 times his age decreased, so minus, decreased by 3 is equal to, so we have the equal sign, 3 times Greg's age, 3 times Greg's age, don't know his age again, increased by 7. Increased means plus 7. How old is Greg? Well, we've got the equation set equal now, and so we can go ahead and solve. So I'm just going to move some terms around. Subtract 3g from all sides, add the 3 to both sides, and we've got our answer. So G equals 10 years. That's how old Greg is. So those are the types of problems you'll see on tonight's homework. Good luck.